short little vignette, I want to show you the importance of using a domain constraint for solving a trigonometric equation, and also to show you the difference between the solve command and also the zeros command. So first of all, what we will do is we'll look at solving a trig equation, and let's say, for example, you've been asked to find the solutions to the equation sine 2x equals a half from 0 to 2 pi. And you could say to yourself, well, okay, let's press menu, and then what we're going to do is 3 for algebra, and then 1 or enter for solve. And all your trig commands are housed obviously inside this trig button here. So if we press trig, and sine seems to be the most popular, so that's why it's placed top left. So inside the bracket there, we'll put in sine 2x equals a half. So we could do 1 divided by 2. There's also a nice feature, the fractions template, so control divided by, and then the numerator box will put in 1, the denominator box will put in 2, and what the syntax for this is solve the equation, comma, for the variable that you want to solve for. Now, in the absence of a domain constraint, what will happen is you'll get a general solution. So if we press enter, see what we get there. We get a general solution, and it's expressed in 2 branches, and this symbol N1 is basically representing a parameter like N or K. So I think it's really important that where possible, have and specify the domain constraint that you've been given. Most of the time you'll be given a domain constraint. There will be the odd occasion where it's up to you to add a domain constraint, and that could be in situations where only positive solutions make sense. For example, if you're solving for t, it only makes sense to deal with time greater than 0 and rejecting negative values for time. What you need to do is big button up takes you to the last output. Big button up again takes you to the last input. With that selected, press enter, brings it down to a new entry line. To add the domain constraint, if we press control equals, now the domain constraint that we're after, it's this vertical bar that you can see on the bottom right there. Now that's called the with or the given command. So this is our domain constraint. Now just a little trick that will save you maybe 1 second in the exam is, rather than scrolling to the right and going down, if you press big button to the left, that will take you there automatically. So with that selected, then you press enter. So the domain constraint, or the with or the given symbol, has now been pasted into the entry line. And so it's going to be 0, and inequality signs are housed within control equals, and so less than or equal to x, and then control equals less than or equal to, and then 2. And we can find pi by pressing the pi button. It's accompanied by some other symbols. That's one possibility. Another possibility is you can also just type in the word pi. See how it comes up there, non-italicized. So the calculator is recognizing that as pi, and we can say to ourselves, well, how many solutions do we expect? We expect 4 solutions, and there they are. So that's using the solve command. There is a command that does the same thing, but specifies the equations in a list, rather than having x equals pi on 12 or x equals 5 pi on 12, etc., etc. Sometimes it's useful to have the solution specified as a list. So let's see how that works. I'll type in, basically redo this entry line from scratch rather than editing, just to show you where the zeros command actually is. So if we press menu, number 3 for algebra, then number 4 for zeros. The zeros command, basically, whatever you type in, it's assumed to be an equation set to 0, right? So see how here we have sine 2x equals a half. That's an equation that's set to a half. But here, if we're using the zeros command, what you would do is you would enter sine 2x minus a half. And that sine 2x minus half is assumed to be set to 0. In other words, sine 2x minus a half equals 0 is an equivalent equation to sine 2x equals a half. So we press trig, sine, and then 2x minus control symbols, that's control divided by 1 on 2, and then comma x, we still need that, and then control equals 1 to the left to get the with or given symbol, and then 0, control equals x, control equals less than or equal to 2 pi. And what we should see this time is the solution specified in list form. And that could be useful if you were asked a question along the lines of, what is the sum of the solutions to the equation sine 2x equals a half for x between 0 and 2 pi? If you had used the solve command, then what you have to do is you have to do some fiddly editing on that line to get the 4 angles, and then introduce addition signs and then sum them together. But your calculator does have a sum command, so if you type in sum, open bracket, go up and grab that list, press enter, and they're the sum of the solutions. So my feeling is that it is worthwhile getting to know the zeros command. I have another short example to illustrate the power of the zeros command, and so I'm going to press Control Dock, and I'm going to add a calculator page, and I'm going to use the assign command, which acts in the same way as the define command. Control symbols template to access the assign command. The assign command is colon equals. What I'm about to show you doesn't work if you use equals. Okay, so it's colon equals. If you're more comfortable using define, which is found under actions, then stick with that. That's no problems at all. So what I want to do here is I want to assign f of x to be x squared multiplied by e to the negative x, and press enter. Now, one important thing here, folks, is don't get mixed up between base e, or e to the power of something, and the letter e. It's a very simple mistake to make. You're dealing with the exponential function. It's e to the x, not letter e. So what we can do now is, let's say we want to differentiate this particular function, and a nice shortcut for differentiation is shift subtraction. Shift subtraction is a good shortcut for pasting into an entry line the differentiate template. So in here we want dx, in here it's f of x, press enter, that's the derivative. Now let's say we want to work out where the gradient is equal to 0, where are the x-coordinates of the stationary points and what are the corresponding function values? Well, it's quite straightforward to do it all in one, basically in an uninterrupted fashion by pressing menu 3 for algebra, 4 for zeros, and then we can grab either the last output or the last input, it doesn't really matter, comma x, press enter. What we've found here is the x-coordinates of the stationary points, x equals 0, x equals 2, and they're in list form. And what we can do now is if we say, let's substitute x equals 0 and x equals 2 into our original function. So it's f, open bracket, go up and grab that list, press enter to bring it down to the entry line that's active, press enter, and they are the corresponding function values. So our stationary points are at 0, 0 and at 2, 4 on E squared. What I'm illustrating there is that when you use the zeros command in this way, what you're doing is you're performing uninterrupted calculations, and my feeling is that that's a little bit of a time saver in the exam.